Hi James, just doing this little video to take you through these Tamura questions. Yeah, they look pretty nasty to be fair. Which one should we do first? I've just worked through these two. I haven't looked at the next two. I will do though. I just thought I'd have a cup of tea and quickly explain this while I remember how it works. Okay, so the way I see it with this one, I thought I might differentiate. Um, and I did differentiate actually, and I got like to 9 equals p to the 4 over 4. And I thought, why did I do that when it's so much easier and quicker to complete the square? You might think, is this really a quadratic? Well, it's not, it's a quartic, but it's a quadratic in disguise, isn't it? Because that is the square of that. Um, it's probably easier to let y equal x to the 4 minus p squared x squared, and then just complete the square as we normally would, except we're treating our variable as x squared, which is being squared, so I'm going to leave that squared. Halve the middle term, take away p squared over 4. Okay, I think that line above it that line should now be equal to the line above it, if you see what I mean. And I've got completed square form, so I can straight away see. And when I differentiated initially, I just kind of looked at what I'd done and thought, well, I probably should have completed the square. And sure enough, I got to this stage. Oh, sorry, look at that, I've made a mistake. That's p to the 4. You know what I'm like, James. I make a mistake in every line of work in, I swear it. Okay, so that's minus p to the 4 over 4. And so 9 is p to the 4 over 4. And I thought, oh, that's cool because I really know p now. I thought what's not cool is like that's only p on its own. It's not squared. That kind of disappointed me a bit. But I'm now going to do exactly the same thing here. I'm going to find the minimum value by completing the square. So x minus p over 2 squared. And then I get minus p squared over 4 this time, plus 6. Yeah. Now, naturally, I don't care about what x value minimizes this. I mean, it's p over 2, but that's not what it's asking for. It's asking for the minimum value, which will, of course, be this little bit on the end. Yeah. So the min value is minus p squared over 4 plus 6. But of course, what is p squared? We can work it out over here, because if we square root both sides, we get 3 is p squared over 2. And I thought, oh, that's lovely. Now I know that like p squared is 6, because now I can just plug it in as minus 6 over 4 plus 6. And so the minimum value is 4.5, I think, because that's minus 1.5 plus 6. So 4.5. And so E, I reckon. So that's how I did that one. I did just check it on the answer key, and I think it said it was correct. But yeah, because I'm not so, like I say, on the Tamu, I don't think I'm definitely going to get it right. No, I make loads of careless errors. This one I thought was quite fun, actually. In many ways, this one kind of stressed me out a little bit more than this one. This one seemed to behave as I would imagine it would do. Now, what do I mean by that? Well, when I see this, like, I think I know what they're doing here. I know what you're doing. I know what you're doing. You're trying to make it look as complicated as possible to make me just think, oh, I can't do 19. I'm going to move on. Well, I'm not going to do that. I'm going to say let u equal 4 to the cos theta times 60. Actually, I didn't write it out like that. Do you know what I actually said? I was like sine squared of stuff equals 3/4. That's genuinely what I wrote down, because it's just stuff. It's got some value. We can sort that out in a second. Let's just rearrange this first. That means sine of stuff is positive or negative root 3 over 2. And naturally, we can invert that, can't we? We need to know our exact trig values, but that means the stuff is... Now, let's do it separately. Oh, where did that go? Let's do this carefully and say, well, okay, so this means either the stuff equals, right, inverse sine of positive root 3 over 2 is 60. Yeah. Don't forget you always get other values though, so we'll write one of them down and we'll put dot 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 just to remind us. Okay. Or stuff equals, okay, when you do inverse sine of minus root 3 over 2, you get minus 60. Now, minus 60 leads us to 180 minus, we get 240, and then 360 plus, we get 300. Yeah, so we've got all of those values. Hopefully this kind of makes sense so far. I'm just checking something because I hadn't actually picked up a calculator yet. Yeah, I was just checking that inverse sine of minus root 3 over 2 is minus 60. The way I was doing that is just in my head, like you've got this like symmetry, haven't you, with sine? Yeah, like sine of 60 is root 3 over 2. It's because it's an odd function, and so
sine of minus x equals minus sine of x, yeah? In other words, if you've got sine of minus 60, that's a minus sine of 60. It's because it's an odd function. But anyway, okay, so those are our two values for stuff. Now, what I then thought was 4 to the cos theta. They're having a laugh there because cos theta fluctuates between -1 and 1, which means this value here is trapped between 4 to the power of -1, which is a quarter, and 4 to the power of 1, which is 4. Yeah, so I know 4 cos theta can only take values from a quarter to 4. So let's try and strip away this. Now, we know that the stuff, let's actually introduce the stuff now, is 4 cos theta to the cos theta times 60 degrees. And this basically equals, maybe equals 60. Let's just take the 60 value first. What would that give us? That would give us 4 to the cos theta is 1. And so that gives us cos theta is 0, yeah? Well, that means that theta, now I can actually find a value of theta. Where is cos 0? It's at 90 degrees. It's also at 270 degrees, yeah? I'll just put some dots here and here, yeah? Okay, I've dealt with that, one of them. Now let's try it on 120, yeah? 4 to the cos theta times 60 is 120. And I wasn't writing it down all neatly like this. I was kind of doing a lot of it quite casually, quickly. But because you know, it's like you haven't got much time in this at all, as you point out. These are, you know, really hard bits. Okay, can we make 4 to the power of something equal to? Yeah, the cos theta is going to be a half. Yeah, 4 to the power of a half means square root of 4, which is 2. Where is that? Where's cos theta a half? Well, it's at 60 degrees or 300 degrees. Put yourself some dots down because, you know, it reminds you there are other solutions. And now, should we try minus 60 as well? You might think, well, I'll just show you the other two. Yeah, because there's two more to do, really. Only two more as well. Because if you try 4 to the cos theta times 60 is, let's try this one first, this 300. I just want to show you how it's not going to work. Because all of a sudden, you've got 4 to the cos theta equals 5. Yeah, that's absurd because the largest value of cos theta is 1. 4 to the power of 1 or less, it's never going to equal 5. So in other words, you can ignore all numbers after that. Yeah, and you can also ignore all the ones coming after you know, the 120 because you can do 360 plus that. You can see that that end's ruled out if you see what I mean. Now, if you try the next value down, we're going to be doing 4 to the cos theta times by 60 is 240. Well, this does give us a solution because you're going to get 4 to the cos theta equals 4, and that means that cos theta must equal 1. Where does cos equal 1? Well, theta is 0 or 360. They could be certainly interesting. And what I'm actually doing is solving this equation because I figure if I can solve it, I can definitely tell you, you know, given that it has exactly 3 solutions, what the value of x will be. Okay, right, what have we got so far? We've got one more to look at, which is this minus 60. It's quite an interesting one because you're going to get 4 to the cos theta equals minus 1. No, you can't get minus 1 from 4 to the cos theta. So this one isn't actually of any use either. You've got to remember, you're basically going with 4 to the cos theta, you're trapped between a quarter and 4. Because 4 to the minus 1 is a quarter and 4 to the power of 1 is 4. And so are we going to get any other answers? No, we're just going to get the one where you get 1, 2, where you get 4 over here. And I don't think we're going to get any others. You know, you can think of the negative ones over here where you're going to have to take 360 away from both of those. So you're going to end up with minus 240. Okay, we'll get minus 4 over there. I suppose this one might give us oh no, because we're still going to have a negative value. It's not negative. See, I'm getting confused now again. But yeah, so that's the key thing. Like, you realize you've just got these values to play with now. Yeah. Now we want them to have just 3 solutions. Yeah, we want it to have just 3 solutions. So what are those 3 solutions going to be, given that this starts from 0? Well, 0, oh, and it is less than or equal to and less than or equal to. Yeah. So you could have 0, you could have 90, and you can have 270. And then you've definitely got 3 solutions. You don't want the 360 one because you only want 3 solutions. So we want this going 0 up to 270. Yeah. Now, how can we make sure then that x takes a value so we have 3 of these in here? Well, if x is on 90, do we still get free values? Yeah, yeah, we do. I'm missing out. It's because it keeps going out on my screen. I'm missing out the 60 here. Let's consider these. I might even start my explanation again. I don't feel like I've done a brilliant job here. Yeah. What solutions do we have? 0, 60, yeah, 90, 300, 270 as well, and 360. Can I rub that out of the way? It's getting right in the way. Yeah. We only want 3 of these to be true. Well, if you think about it, we're doing naught is less than or equal to theta is less than x, and we're trying to determine what x should be. Yeah. Well, if x is like, say, oh, it's less than or equal to x. If x is 90, yeah, that's fine because we get 3 solutions: 0, 60, 90. That's cool. Any less than 90, though, that's no good. So I can say that 90 is definitely going to be less than or equal to x. Now, how large can I make this to make sure that I don't get a fourth solution? Well, I can take it right the way up to, but not including 270, because that's where the next solution is. Hence, that's the answer. Yeah, 90 to 270. B. That's how I did that one. I don't know if it makes sense. It was kind of a bit crazy. I kind of enjoyed that one. I found that one quite fun. This was a little bit, yeah, it was not. It was quite good fun still, but it wasn't. It kind of stressed me out, to be honest, because I'd just done some differentiation and then did like one line of working and got the answer of what 4 lines of working was really quickly. Anyway, I hope that was useful, James. I'm going to do the other 2 questions right now. I'm just going to make myself a cup of tea. So yeah, well done. Keep up the hard work and good luck tomorrow.